Hello and welcome to this webinar hosted by Mango Solutions on an introduction to R. My name is Joe Russell. I am one of the data scientists here at Mango and I'm going to be giving this webinar. So what can you first expect from this webinar? Well, to start with, I'm going to very briefly touch on who Mango are, and then we're going to jump into an introduction to R, and starting with why R. So why do you want to use R? Then we're going to look at what's possible within R, and I'm going to be giving you some demonstrations along with that. And then finally, we're going to look at how you can actually go away and learn R for yourself. So as I said, a little bit about Mango. So Mango are a data science consultancy. We are based in Bristol, Chippenham and London, and we offer data science capabilities in three main areas. These are data science, data engineering, and data products. And through these three areas, Mango empowers organizations to make informed decisions using sophisticated techniques such as AI and machine learning in order to deliver data-driven value. And Mango really does this across many sectors. So that's all I've got to say about Mango. So let's jump right in about R. So to begin with, why do you even want to bother with R? So why R? Let's say you're an Excel user and you perform all your day-to-day tasks in Excel. Why do you have to go away and learn a whole nother language, a whole nother program to use? Why is this going to be beneficial to you? And it can sometimes seem like this little image that we've got here, where someone's climbing up a hill and they think they're kind of becoming an expert in this thing, and they kind of look over the hill and oh my gosh, there's a whole nother peak to climb. And this can be quite intimidating because you might think that learning new stuff, such as learning R, will require a significant amount of time and effort, and this can be quite off-putting. But I really want today to tell you why this is really beneficial to you and how this can be beneficial for your day-to-day work. So I'm going to give you some reasons. So the first reason is that R's reproducibility. Now, what do I mean by reproducibility? Well, the definition of reproducibility is that something is able to be reproduced or copied from one place to another. And within R terms, this means that I can perform an analysis. I can then send that to someone else, and we can both run those two analyses at the same time, and we can get exactly the same results. This is really important when working within an organization, because when you're performing an analysis, you want to be sure that someone somewhere else within the organization will get the same results. And so R is really good for this. Okay, reason number two why you want to start using R is because R is open source. And this means that R is original code is freely available and can be redistributed and modified. So that first bit is really key. So R is freely available, i.e. R is free. We don't have to pay for R. Whereas other programs, you may have to go away and pay for it with an expensive license. R is absolutely free. You're able to just go onto the internet and download it as you wish. But it's also available to be modified and redistributed. And this means that we are able to write extensions to R. So we can make R be able to do further things that maybe is not currently able to do. We can go away and write these extensions. This is using something called an R package, which we will learn more about later. Okay, another reason why you want to start using R is because R is platform independent. So this means that R can be used on, here we've got three pictures of a Windows machine, Apple and Linux. And R can be used on all three of these machines. And this is again relating back to that reproducibility. So if I'm sat here on a Windows laptop and I want to send one of my colleagues an analysis and they are working on an Apple laptop, well, then I can send them that analysis and they can run through it and they will get exactly the same output as I did because R is platform independent. Okay, the next reason why you want to start using R is because R connects with other languages. So R is not just within itself. When R first started, it was mainly built with people connecting to R and something called Fortran and C. Because as R became more and more popular, people from other languages started to come with their own workflows, and they wanted to convert those workflows to be used within R. And so people started to write some extensions. They started to create their own packages that allowed them to connect their old workflows into R. So this means that today we have many, many ways of connecting with other languages. Some of the most popular of these including C++, Java, and Python. So another reason why you want to start using R is because of R's documentation. R has a myriad of documentation available for the user if they're just getting started and want to learn more about R. This can range from the R core team, the people who kind of keep R going and keep updating R. They have produced some official documentation about how to use R. But even more generally, when people write extensions to R and they make these publicly available, there is a strict requirement that they have to produce documentation on these extensions. So this means that anyone can come in, look at these extensions that are publicly available, and read the documentation and instantly have an idea of how this extension is meant to be used. And finally, why you want to start using R is because of the community. Now, there's a saying that if you want software to really thrive, it requires a really, really good community, and R definitely has this. So some of the just examples of the community we have on Twitter, there's a hashtag called RStats, and if you include that in any of your tweets, you'll almost certainly get likes and retweets and comments from others in the RStats community. There's also other things such as R Bloggers, which is a website for all blogs relating to R. If you just search Google for R Bloggers, you'll come up with R Bloggers. But then there's other websites such as Stack Overflow, which you might have heard of as well, where people can ask for help and someone from the R community will be able to provide an answer to them. But there's also, even on a more local scale, we have lots of R meetups. So for me personally in Chippenham, the most local meetup is called Bristol R, which I've attended, and it's a really good way of learning new ideas of what's possible within R. So that's why you actually want to start using R. And now we're going to be looking at what's actually possible within R. So what am I going to be able to do when I start using R? So we're going to be looking at R in the world of analytics. And when we perform kind of analytics, when we perform analyses within R, there is one kind of key extension, one key package that we're going to be using, and that is called the TidyVerse. And what is the TidyVerse? Well, the TidyVerse is a coherent system of packages for data manipulation, exploration, and visualization that all share a common philosophy. So here we can see we've got a nice graphic telling us that TidyVerse includes the importing, tidying, the transforming, visualizing, modeling, and the communication all of data. So it's a really, really powerful tool for performing analysis. Now, TidyVerse is actually kind of a special package in that it's made up of many other packages. So some of these packages include readr, readxl for importing data, the Tibble package or tidyr for tidying, as well as packages such as dplyr, ggplot2, forcats, and many others for manipulating, visualizing, and communicating results from an analysis. And these kind of fundamentally together, they build up what the TidyVerse is. And there's a really nice quote here from Hal Abelson, and it says, "Programs must be written for people to read and only incidentally for machines to execute." And the TidyVerse is really built on this philosophy, in that the code that is written, the syntax that you use is really easy to understand for a human, and the kind of machine is only incidentally used to execute it. So this means that when you perform an analysis and you share it with someone, they can really quickly and really easily understand what you've done to make these analyses. And this is why it's such a great tool. So let's have some demonstrations. So firstly, talking about data importing. So you might be an Excel user, you might have lots of data stored in Excel files or in CSVs, or even some of these other sources that we have pictures of here. And we can import all of these data sources within R. And so we're going to have a little demonstration of this. So I'm going to quickly jump over to the RStudio interface. Now, RStudio is just the interface that is the most popular interface for when anyone is using R. So whenever you perform an analysis, you want to be using the RStudio interface. And let's have a quick demonstration of data importing. So I'm going to put a little title here saying that I'm performing some data importing. And when I import some data from outside of R into R, I'm going to be using a package or an extension called the readr package. And to use this, I'm going to first just load it in. I'm going to be using a function called library, and then I'm going to call my package, which is readr. And this is going to load in this set of functions from this package. Now, when I've done this, I'm going to say that I want to read a CSV file. And to do so, all I need to do is use a function called, very naturally called read CSV. This is again, this is the importance of the code being readable to humans. So read CSV, it's really clear what I'm doing here. I'm reading a CSV. And now all we need to do with this function is we just provide the file we want to read in. So in this case, I want to read in this file called iris CSV. And when I do so, we can see that we have something execute here in something called the console. And this is, we can see here, we have this data frame here, which is in fact this iris CSV. And we have read this within R. So because we just ran this code and it printed to this console, but let's say we want to actually do something with this data frame that we've just read in. So we can assign this to an object. So I'm going to assign this to an object called iris CSV. And now we have this iris CSV object that is in our environment. And this just means that we can access this data set anytime, and we don't have to keep reading it in every time. So now I can do things such as view the data using a function called view. And all I need to do is tell it what data set I want to view. I'm going to view this iris CSV that I've just read in. And here we can see we have a nice viewing of our data set. So we can scroll down and see all the data within this data set. So that was a really easy way of reading in a CSV file. But sometimes you might have, let's say you have an Excel file that you want to read into R. And to do this, I'm going to be using a package called read Excel. Again, I'm going to be loading in all the functions from this read Excel package using this library. And I'm going to create a comment here saying read an Excel file. And in much the same way as before, we're going to be using a function called read Excel. And this time, instead of the iris CSV I'm reading from, we're going to be reading from the iris Excel file. And again, when I run that, you can see that in the console here, we have this data set has been printed again. So again, let's assign this to an object. So I'm going to call this iris XLS. And if we wanted to, we can again view this iris XLS data set, which as it turns out is exactly the same as the CSV. So that's a really, really simple overview of how we can import data into R. So data import, you can do it. Great. So next step we're going to be looking at within the TidyVerse structure is the data wrangling, and we're going to be doing this using something called the dplyr package. So data wrangling is when we have our data, but we want to change it, we want to modify it, so we can do things such as summarize. So we can kind of create a summary of our data. So kind of, let's say we want to calculate the mean. We can do that using a summarize. We can mutate, which means add on extra columns. We can do a select, which means we can select only certain columns, or we could even do a filter, which means we want to only filter to certain rows, so we want to exclude some rows from our data set. So again, you can do this in R. So let's have a go. Let's jump back to our studio and have a go at some data wrangling. So to do this, we're going to be using the package or the extension called dplyr. And loading that in, we now have functions available in the dplyr package. And we're going to be using the dataset that we're running called iris CSV. So currently this looks, let's again go for a view of this iris CSV. Currently this is a dataset with 5 columns: sepal length, sepal width, petal length, petal width, and species. And this has 150 rows, so 50 and 150 rows, 50 rows for each of these 3 species in the species column. But let's perform some data wrangling on this data set. So first, we're going to be calling our data frame, and then we're going to be using something special from the dplyr package called the pipe. Now, all this is a special thing that tells us whatever we have on the left, we're going to be doing something. We're going to pass it into the thing on the right. And so we're going to be taking our data frame, and let's say we want to select only certain columns. So let's say we've got our data set and we want to select only the columns that begin with the word sepal. So we want to select sepal length and sepal width. And let's say we also want to select the species column. And we can do this with functions from the dplyr package. So let's use the function called select. And because we've used this pipe, we are going to we are sending this iris CSV into our select function, and then we just need to tell it what we want to select. So we are going to tell dplyr that we want to select all the columns that contain the word sepal, but we also want to select all the columns that are called species. Now if I run this, and we look up here in the console, we can see that we only have 3 columns, one called sepal length, one called sepal width, and species. So we have managed to select just the columns called sepal and species. So great, now we've got a slightly more streamlined data set. Let's say we actually want to filter some of these rows. So let's say we want to only have values where the sepal length is greater than 5. And again, we can do this using this pipe, but this time we're going to be using a function called filter. And all we need to do within inside this filter function is we need to specify the column that we want to apply a filter on. So we're going to be applying a filter on the sepal length column, and then we just need to tell it what values we want to filter for in this column. So we want to select values that are greater than 5. So we tell it we want to filter sepal length greater than 5. So now we can see, as before, we had values of 4.6, 4.7, but when we run this new code, we can see that those values are now gone, and we only have values where the sepal length is greater than 5. Okay, great. So we've looked at selecting columns and filtering rows. Next, we might want to add a new column in. So again, we can do this using our special thing called a pipe, but this time we're going to be using a function called mutate. And this function basically means add a new column on. And all we need to do with inside this function is tell it the new column that we want to create. So in this example, let's create a column called sepal area. And then we just need to tell it what we want the values in this column to be. So we are going to create this using the multiplication of sepal length times sepal width. So that's all we need to tell it. We need to tell it we want to take the sepal length and multiply it by the sepal width. And when we run this, we can see that we have a fourth column called sepal area, which is just the values of sepal length times by sepal width. So that's creating a new column. We also might want to perform some summaries. So we can do that using the summarize function. But before we do that, we need to perform some groupings on our data. And to perform a grouping, we can use this function called group by. And in this example, we're going to group by the species column. And when we run this, we can see that actually nothing's changed within our data. The only thing that we have new now is this little text up here in the top that says groups. And then it tells us that we have grouped by the species column, and that within this column there are 3 groupings. So there are 3 different types of species. And the data has been grouped, so we've told the data that these groupings are all related. So all the species called Setosa are related, and we're going to group them together. And now we can perform a summary of these groupings, which is really powerful. So we do this using the function called summarize. And let's say we wanted to calculate the average sepal length for each of these species. So we can do that using the summarize function. First, we just need to define the column that we want these values to go into. So we're going to call it mean sepal length. And then we're going to use the function called mean to calculate the average. And then we just tell it of which column we want to calculate this for. So when we run this, we can see we get a much smaller data set, which has these 3 groupings in it. So Setosa, versicolor, virginica, these are our 3 species groups. And then for each of these groups, the summarize has calculated the average sepal length for each of these groups. So this is really powerful in producing quick summaries. We might want to produce some more summaries, so we could say let's also calculate the mean sepal width. So we can do that in exactly the same way using the mean function. And we also might want to calculate the average sepal area, the column that we produced earlier. So let's calculate this in exactly the same way. And when we run this, we can see that we have another summary table, this time with values for mean sepal length, the mean sepal width, and the mean sepal area, each of our three species. And so, yeah, we can really quickly see that, okay, the mean sepal area is 19.8 for Setosa and Virginica, but it's a bit smaller for versicolor. And hopefully you agree with me, this is a really easy to read way. So we can see, if we go back, we can see we started with our data set, we've selected the columns, we've filtered the rows, we've mutated new columns, we've grouped by, and then we've calculated a summary at the end of that to produce our final table here. And that is how kind of a really basic example of performing data wrangling within R. So next thing you can do in R is statistics, machine learning, and AI. Now, machine learning and AI is probably slightly too advanced for an intro to R course, but it is absolutely possible. But yeah, these can perform, along with visualizations here, we've got some pretty cool visualizations of different statistical analyses that have been performed. So here we've got some correlation plots, time series data, bar charts, you name it. But you can do all of this within R. So I'm going to give you a really light example here of what you can do. So I'm going to create a title for statistics. And just the example that we're going to be using here, we don't need to load any extra packages in. But let's say we wanted to fit a linear model in R. So doing that within R is really, really easy. We can use a function called LM, which stands for linear model. And then all we want to do with our linear model is we want to say the thing that we are going to try and predict. So then let's say we want to predict the sepal width in our data, and we can say we want to predict the sepal width based on all the other columns in our data set. And then we're just going to provide the data that we have. So we're going to provide our iris CSV data set. And when we run this, we can see we've got another output, which looks slightly different to our table from before. But here we can see it's told us that we've called a linear model. It's told us what the formula that we've provided was and the data we've provided. And it's produced some coefficients for each of the variables that we're trying to predict sepal width with. So a similar way that we performed earlier, we can assign this linear model to an object. So let's assign it to an object called LM model. And then we can do kind of further things with it. So we might want to produce kind of a summary of results on this linear model, and we can do that with the summary function. So if I run a summary on this LM model, I can see that we get kind of a more in-depth output about our model here. So we can see we have this output here that is talking about the sepal length, the petal width, and then the two species. And we can see we've got these little stars here, and this is referring to the p-value of these variables, so how good these variables are at predicting the sepal width that we told it to. And so, for example, here we can see that the sepal length is really, really good at predicting the sepal width. In fact, its p-value is less than 0.001. So really strong evidence there. And this is like a really, really basic example of R trying to predict something with a model. But there are much more advanced methods for machine learning and AI as well, if you want to go away and learn that. So not only statistics, we can also perform data visualization. And we've got loads of plots here that I'm going to show you and quickly flick through. That I hope you agree with me that look, some of these are really, really cool, and some of them you might even be surprised that R could be produced in R. I think there's quite a stigma around R that the kind of the graphics and the visualizations are quite poor, but I think actually visualization in R is really one of its strong points. So all of these pictures that I'm going to show you now are all created within R. So some of these you might recognise from BBC News. So in fact, the BBC produce all their plots within R, and these are some of the ones that they've produced recently. You can also produce plots such as these, or this, or even graphical data, and the list goes on. There's loads of visualizations that R can perform. So let's have a few examples of these. So this is really cool. Now, the main package that we use for visualization in R is called the ggplot2 package. So to use this, we're going to have to load it in. And once we've done this, we can start to produce some visualizations. So to do this, we need to use a function called ggplot. We provide our data set that we want to plot. So I'm going to be plotting our iris CSV from before, and then we can provide we can tell it what we want to plot. So let's say we want to plot our sepal width along the x-axis, and let's say we want to create a histogram. So I can do this using something called a geometry, which is shortened to geom, and I just need to tell it that I want to use a geom histogram. And when I run this code is going to just go away. It's going to use sepal width as the x-axis, and then it's going to create a histogram with my data. Now this is a really basic plot, but we can do some quite cool things with it to make it a bit more complex. So I could, let's say I wanted to change the color depending on which species the data was from. And we can do that. So now we can see here that we've got the Setosa species is all coloured red. Similarly, versicolor is green and virginica is blue. But we might want to do, this is quite confusing, so we might want to split these out into their own little separate plots. And we can do this using a function called facet wrap. And then I'm going to tell it that I want to create a separate plot for each different species. And when I do this, we can see we've got a nice histogram split by each of these 3 species. Now we might want to have a bit more control, so we might want to remove the legend. So I could do this using the guides function and tell it that I don't want this, this fill legend to appear here. And that is going to make that disappear. I could also add some more some visual elements, so I could change what I want the theme of the plot to be using this theme BW, so theme black and white function, and this is going to change the overall visualization of the plot. So you can see we've got a nice black outline to each of the plots. And I might even want to do something slightly more complex. So in this example, I'm going to create another histogram. But let's say I want to overlay a whole data set behind each of these. So I want to see, kind of treat these histograms as a highlighting of the data for each of those species. So what I could do here is I could take our iris CSV and I could just remove the 5th column, remove the species column. And I could color these histograms in a color gray. And then I could specify how dark I want these colors to appear. So I'm just going to call this alpha 0.8. So I want it to be slightly lighter. And when I do this, so I just need to define that this is my data. And when I run this, apologies, add that. When I run this, we get this quite cool plot actually. So now we have a histogram of the whole data set in each of these little smaller plots. And then we just have the histogram for each of the species highlighted within over the top of this whole data set. So this is quite a cool plot, and we've whipped this up in next to no time. So this is really cool. So let's have a few more examples of the kind of plots that we could create. So we looked at a histogram so far, but we might want to look at a box plot. And again, these are really easy to use in R, easy to create. So again, we use the ggplot function, and we specify the data that we want to use. And this time we're going to say that we want our x-axis to be the species, we want our y-axis to be the C4 length. And this time, instead of telling it to use a histogram geometry, I'm going to use a box plot geometry. And when I do this, we get a nice plot that we've created very quickly. And again, we might want to change this up slightly. So we could say we want to vary the color depending on the species. So for each of these different species, we're going to make them a different color. And it's given us these red, green, and blue outlines. But let's say we wanted to actually control these colors instead. So we could do this using a function called scale color manual. And all we need to do now is tell it the values that we want these colors to be. So I could say I want this to be black. I want the next one to be blue. And I want the final one to be, let's go for dark orange. And when I run that, we can see that it has taken these values and it's colored each of these boxes in the color that I specified. And that's a really cool way to do this. We could have used this scale color manual on our histogram above. So that's creating a box plot really quickly. We could also we could plot a linear model. So this time I'm going to be creating a scatter plot and then overlaying a linear model on top of that scatter plot. So again, I'm going to be using this ggplot function, specifying the iris ESV data. And this time we're going to be plotting a sepal length on the x-axis and a sepal width on the y-axis. And then let's color each of these points depending on the species. And then in this time, instead of using a box plot or a histogram, we're going to be using a scatter plot. And I'm going to do this using the geom point function. And when I run this, we get a nice picture of the sepal length against sepal width for each of our species, colored by each of our species. Now, those points are quite small, so let's bump them up a little bit. So I could say, oh, my size of my points to be a little bit bigger. So I could say size equals to 3. And our points will get a little bit bigger. We could, let's change the x and y axis. So I could use that using the xlab function to change the x axis. I could say, we could change this to sepal length in centimeters. Similarly, we could use the ylab function and say sepal width, also in centimeters. And we can also, let's add a title to our plot using the ggtitle function and say scatter plot. And when we run that, we will see that we have updated our axes to what we specified. So let's try and plot a linear model for each of these. So we've just used a geom point so far, but we could also add another geometry on top of this. And to do that, we're going to be using a geometry called geom smooth. So inserting that in here, all I need to do is call this geom smooth, and I need to tell it what kind of method I want to use to fit this model. So I'm going to be telling it to use the linear model method. And when I add this, and let's have a closer look at this, we can see that for each of the 3 species, ggplot has fitted a linear model onto our data. So we can see here the Setosa species has a linear model of values that where the sepal width is slightly higher compared to the sepal length, whereas Versicolor and Virginica are slightly more correlated. And so I hope you agree that was kind of quite easy, and we've produced some quite nice visuals within ggplot. So data visualization, you can do it. Another thing you might want to be able to do is automated reporting. And R, again, is really, really good at performing automated reporting. So again, automated reporting, you can do it. So let's jump over back to RStudio. And to do this, all you need to do is go to this File button up here in the top left, click New File, and then click on the R Markdown. And that will create this little window to pop up here. And I'm just going to call this title of this R Markdown, our webinar markdown, webinar report, let's call it. And when we do that, we see that we get this template for this markdown document that will create a report. This has included our title that I entered, as well as my name as the author, the date. And we can see we've got some kind of headings, some text, some R code that is being performed, as well as a plot, a generation of a plot based on some data. And so when we've kind of done this, this is all kind of freely editable, so I can add my own words in here. This is my new report. And when we've done kind of editing this, we can press this button called knit. And this will prompt us to save our report. So I'm going to save this as our webinar report. Click Save. And once it is finished running, we can see we get this really nice report that's outputted. It is taken all our text that we entered, it is nicely formatted our titles, and it is also executed the R code that we specified. So it's produced a summary of this cars data set, and it has also created a plot based on the data that we provided in the Markdown script. So R is really, really powerful at producing these reports. These don't have to, so we just created a HTML output, but you can also produce these as PDFs or even Word documents as well. So this is a really, really easy and consistent way of providing outputs to our analyses. So another way you can communicate from R is with these two packages called Bookdown and Blogdown. Now, I'm not going to show you actual examples of these, but I'm just going to quickly show you to a link on the internet. And this is a blog that has been written. This is Kasia. She is another data scientist at Mango, and she has a blog that she regularly writes to. And she writes all of this. She writes all of this using R. So you can see here she's written a blog about web scraping with R, and she's performed all of this using the Blogdown package. And I'm sure you agree this looks really, really nice, and it's really, really simple compared to other methods of producing a blog. You can also produce books. There are lots of books that I'll touch on later in the How to Learn R chapter, but you can also produce books from R. So another thing you can produce are shiny applications and dashboards, and these are basically just, they're just applications or dashboards, if you like, that you produce within R. And these can look anywhere from like this, and I'm sure you agree these look quite cool, and you might be surprised that you can just produce these cool looking dashboards all within R. Again, I'm going to jump and show you some cool examples online. So if you go to the RStudio Shiny gallery, they have a lot of examples of Shiny apps that you are able to produce. And if you click on any one of these examples, let's go for this one. It has links to both view the app and also view the code. So if you wanted to create your own version of the app, you could do so looking at this code. So let's view the app. And this one is quite cool. It's got a plot of the world that is interactive that I can zoom around in. And it's got this little search function here. So I could search England. I could click find crime. And when I do that, it performs some calculations, and it says crimes within 1 mile of England, and it's produced a little bar plot here. But this is really cool. So this is all produced within R, just using R code, which is really, really cool. So that's kind of a summary of what's possible within R. But so you've actually, hopefully I've convinced you that R has many different possibilities. So you're thinking, how can I actually go and get started with R? How can I go and learn R? And I've created just a list of free resources here. As I said, because R is open source and because there's such a community to it, all of these resources are free, which is absolutely incredible. So as I touched on before, there's lots of online books. These can range from performing data science within R, to visualizations in R, to much more complicated things such as machine learning in R. There are free books available on the RStudio website for these. There's also a package called the Swirl package, which if you install is a really kind of interactive way of learning R and how to code in R. You could also simply just Google Learn R for free. And if you do this, you'll come up with a multitude of options where you can learn R for free. There's blog posts, which we've kind of showed that have been, such as Cash's one, that give you new examples of things you can do in R. But as well, there's YouTube and other websites that have lots and lots of examples of things you can do in R and walkthroughs, such as this one. And finally, you have meetups that I kind of mentioned before, meetups such as London R or Bristol R or R Ladies London. These are all really cool meetups where you can go and see how other people are using R. So, kind of to wrap up, what is the take-home message from this webinar? So firstly, the thing is that there are lots and lots of good reasons to start learning R. Lots of reasons to make your day-to-day life, the tasks you perform at work, much simpler, and make more reproducible and connecting with other things that you do. Second reason that R is intuitive and powerful. So I hope you agree with some of the analyses that we performed might seem quite complex, but actually if you were to go away and show these to someone else, they are quite readable. Someone with not too much experience should be able to go and pick up on what we have performed. Thirdly, there are lots of free resources out there. This is touching back to R being open source. There's loads and loads of free resources, so you don't have to spend lots and lots of money trying to learn how to use R. And so with all that combined, there is nothing to stop you from starting to use R right now. So that's great. So just to conclude, I'd just like to thank you for attending this webinar. Hopefully you've found it inspiring and you're convinced you to go away and start learning R. These webinars have been produced by Mango Solutions, and if you wanted to get in contact, we have the contact details on the screen there. So thank you very much for attending, and goodbye.